Hello everyone. Today we begin our exploration into a critical topic, the introduction to climate change, understanding its fundamental aspects. We will start by gaining a deeper understanding of our Earth's climate system and how it naturally operates. First, let us define climate change, a term frequently discussed but often misunderstood in daily conversations. It refers to significant, long-term alterations in global or regional climate patterns over extended periods. Climate change encompasses broad shifts in various aspects of our global climate, affecting many systems. These shifts include changes in temperature, precipitation patterns, and rising sea levels across the globe. Global warming specifically refers to the ongoing rise in Earth's average temperature, a key component. It is the specific increase in the planet's average temperature, primarily due to trapped greenhouse gases. Many of these accelerated changes are predominantly human-induced, resulting from our activities on Earth. Human activities are significantly accelerating these changes, impacting the natural balance of our planet. However, it is also important to remember that climate change can occur naturally due to Earth's processes. Natural factors like volcanic eruptions or solar cycles can also cause shifts in global climate. Now, let us examine the main drivers of climate change, both natural and human-induced. We will compare the natural processes that influence climate with the significant impact of human activities. On one side, we have natural causes which have influenced Earth's climate for millennia. Volcanic eruptions, for instance, solar variability, like changes in the sun's energy output, also impacts Earth's overall climate. Ocean currents play a crucial role in regulating global climate patterns by distributing heat. On the other side, we explore human-induced causes which have become dominant in recent times. Greenhouse gas, GHG, emissions from burning fossil fuels are a primary human contributor. Deforestation, the clearing of forests, reduces the Earth's ability to absorb carbon dioxide. Industrial activities such as manufacturing also release significant amounts of greenhouse gases. Urbanization and the growth of cities contribute to increased energy use and heat retention. Let us now focus on the main greenhouse gases which are crucial to understanding climate change. These are the gases in our atmosphere that effectively trap heat, warming the Earth. First, we have carbon dioxide, CO2, a major greenhouse gas from various sources. Its primary source is the burning of fossil fuels for energy and transportation worldwide. Deforestation also contributes, as trees absorb carbon dioxide and their removal releases it. Carbon dioxide remains in the atmosphere for centuries, acting as a long-term climate driver. Next is methane, CH4, another potent greenhouse gas with significant warming potential. Sources include livestock, natural wetlands, and landfills where organic waste decomposes. Methane is approximately 25 times more potent than carbon dioxide at trapping heat. While it stays in the atmosphere for a shorter time, methane has a stronger short-term warming effect. Then there is nitrous oxide, N2O, which also contributes to global warming. It mainly comes from agricultural activities, particularly the use of synthetic fertilizers on crops. Nitrous oxide is 298 times more potent than carbon dioxide over a century. Beyond warming, nitrous oxide also contributes to the depletion of Earth's protective ozone layer. Finally, CFCs and HFCs are powerful synthetic greenhouse gases. These are commonly found in refrigerants and air conditioning systems, though their use is declining. They are thousands of times more potent than carbon dioxide, even in small quantities. Some of these compounds are also known to destroy the stratospheric ozone layer, a critical shield. Now, let's understand how the greenhouse effect works, a natural process vital for life. First, solar radiation from the sun enters Earth's atmosphere, bringing light and energy. The Earth's surface absorbs this energy and then re-emits it as infrared heat. Greenhouse gases in the atmosphere then trap some of this re-emitted heat, preventing its escape. This trapped heat keeps our planet warm enough to sustain life, a natural balance. Let us now consider the broad impacts of climate change affecting many aspects of life. These impacts extend across our environment, global economy, and human society as a whole. Environmentally, we observe significant changes across our planet's natural systems. This includes rising global temperatures, melting ice, and more frequent extreme weather events. Economically, climate change poses substantial challenges to various sectors worldwide. We see disruptions in agriculture, damage to infrastructure, and increased energy costs. From a social and health perspective, the impacts are deeply felt by communities. This leads to issues like heat stroke, respiratory diseases, and the displacement of climate refugees. Now, we will explore global mitigation strategies, crucial actions for a sustainable future. These are the essential steps we can take to reduce climate change and build a better future. One key area is reducing carbon dioxide, CO2, emissions, our largest challenge. Switching to renewable energy sources like solar and wind power is a top priority. Enhancing energy efficiency in homes and industries also significantly reduces carbon footprint. Promoting reforestation efforts helps absorb carbon dioxide as trees act as natural carbon sinks. Another vital strategy focuses on reducing methane, CH4, emissions globally. Implementing sustainable agriculture practices, including improved livestock management, can lower methane output. Reducing food waste that ends up in landfills can significantly decrease methane production. Improving livestock management through better feed and practices helps lessen methane emissions from animals. We also need to focus on reducing nitrous oxide N2O emissions effectively. Optimizing fertilizer use in agriculture can drastically cut down on nitrous oxide release. Regulating industrial emissions with stricter standards is essential to control this powerful gas. Adopting precision agriculture techniques helps apply fertilizers more efficiently, minimizing waste and emissions. Let's take a brief journey through Earth's ancient climate history, spanning vast eras. During the Precambrian era, Earth experienced early ice ages with a carbon dioxide-rich atmosphere. The Mesozoic era, the age of dinosaurs, had a much warmer climate due to high carbon dioxide levels. The Cenozoic era saw gradual cooling, leading to the formation of our planet's polar ice sheets. The Pleistocene Ice Age was characterized by vast glaciers covering continents and significantly lower sea levels. We are currently in the Holocene epoch, an interglacial period that allowed agricultural development to flourish. Now, let us delve deeper into the natural climate drivers that influence Earth's climate. These are the inherent processes that naturally shape our planet's climate over time. Solar variability refers to the natural fluctuations in the sun's energy output over cycles. The amount of energy the sun emits naturally fluctuates, influencing Earth's temperatures. These changes in solar activity can directly affect Earth's average global temperature. A historical example is the Maunder minimum, a period of reduced solar activity and cooler temperatures. Volcanic eruptions are another powerful natural driver, significantly impacting global climate temporarily. Large eruptions release ash and gases into the atmosphere, which can block incoming sunlight. This blocking effect often leads to a temporary global cooling as less solar energy reaches the surface. The 1815 Mount Tambora eruption, for instance, caused a year without a summer. Ocean currents also play a vital role, acting as a global conveyor belt for heat. They regulate global climate by distributing heat from the equator towards the poles. For example, El Niño, pronounced El Niño, events cause widespread warming of ocean surface temperatures. Conversely, La Nina, pronounced La Niña, events typically bring about a global cooling effect. Finally, Milankovitch cycles describe changes in Earth's orbit and axial tilt. Over thousands of years, Earth's orbital path and its axial tilt slowly change. These changes affect how solar energy is distributed across the planet, influencing seasons. Historically, these cycles have been responsible for triggering the Earth's major ice ages. Now, we turn to human-induced climate drivers, the key activities accelerating global warming. These are the significant human activities that are rapidly increasing the Earth's average temperature. Burning fossil fuels is a primary human activity driving climate change today. This involves the combustion of coal, oil, and natural gas to generate energy. Burning these fuels releases vast amounts of carbon dioxide, CO2, and other greenhouse gases. Major uses include electricity generation, powering our homes, and transportation worldwide. Deforestation, the clearing of forests, is another major human-induced climate driver. It reduces Earth's natural carbon sinks, which are vital for absorbing atmospheric carbon dioxide. When trees are cut down or burned, they release the carbon they have stored. This is part of broader land use changes that impact global carbon cycles significantly. Industrial activities and agriculture also contribute significantly to greenhouse gas emissions. Manufacturing processes like cement and steel production are large emitters of carbon dioxide. Livestock, particularly cattle, produce significant amounts of methane, CH4, a potent greenhouse gas. Agricultural fertilizers release nitrous oxide, N2O, another powerful greenhouse gas into the atmosphere. Urbanization, the expansion of cities, further exacerbates climate change impacts. Growing urban areas demand increased energy for buildings, transport, and other infrastructure. Cities often create urban heat islands, trapping more heat due to concrete and asphalt. Increased waste generation in cities also contributes to methane emissions from landfills. To conclude our session, let us review the key takeaways from today's discussion. These are the essential points that we should all remember about climate change. Remember, climate change involves long-term shifts in our global climate patterns and averages. Both natural processes and human activities are responsible for driving these climate changes. Greenhouse gases effectively trap heat in the atmosphere, leading to global warming. Human emissions are undeniably accelerating the current warming trend at an unprecedented rate. The widespread impacts affect our environment, the global economy, and human health. Therefore, implementing mitigation strategies is essential for building a more sustainable future for everyone.